All right, let's have a look here. We're given x and y. Need to zoom in a bit here. We're given x and y, and we have to calculate x squared plus y squared and y over x. All right. Let's see. X squared plus y squared. X squared is 1 plus 4i minus 4, and y squared is 9 plus 6i minus 1. So I can see that the 1's cancel there. And I get a 10i and a 5. 5 plus 10i, it looks like. 9 minus 4 is 5. Yeah, okay. And then y over x is 3 plus I over 1 plus 2i times the conjugate of the denominator. So on the bottom, I get 5 when I multiply these out. And on the top, I get 3 minus 6i plus I minus 2i squared. So that would be 5 minus 5i over 5. So that's 1 minus I. So that first part is done. And now on to the second part. The second part now, there was a factorization technique suggested by Wilhelm Villedad, I think. Oh, let me see if I can get the name here. You posted in a comment a few videos ago. Wassim Villedad, I believe, suggested a factorization technique here, which I'm going to try. It worked the last time I did it, thank you. So let's see if it works again. So this is equal to x4 plus 5x squared minus 2 plus 4x cubed plus 2x. So here I can take out 2x and I'm left with x squared plus 1. And here I can factorize this as x squared plus 1 times x squared minus 2 maybe. That's x4, that's minus 2. Now, that didn't quite... Oh, sorry, that's a 2 there. So, that's... Oh, so maybe this doesn't quite work this time. Oh, no, does it not work? Ah... x4 plus 5x squared minus 2 plus 4x cubed. I don't think I can factorize this to get this because the 2, but I wonder if I can do something a bit sneaky with the 2. I don't know. Because I would need this to be something like This one's a tricky one. I wonder if there's a long division. It says find the quadratic factor, so actually I know it has 2 quadratic factors. Okay, let me think for 1 sec before I jump in again. Okay, let's push on with this. I think that grouping technique, it worked in the other examples, and my factorization, to be honest, is not like stellar fantastic when it comes to things more complicated than a cubic, to be honest, because I've not had much cause to practice it, frankly. It's a quadratics. It's 2 quadratic factors. So we can see that it has to be x squared at the front because that's the only way to make an x4 here. And the only way to get minus 2 is with a plus 1 and minus 2. So I'm just unsure about the middle coefficient here and here. It might not be too bad. Let's see. How could we make the 2 here? That is, how could we get the x terms? So that would be alpha x times minus 2. So that's minus 2 alpha x. And 1 times beta x. And that's supposed to equal 2x. So I can see that beta minus 2 alpha should equal 2. Okay. That looks okay, I think. Why did I say minus here though? Oh yeah, minus 2. So yeah. Okay. Whoops. Oh, and I just realized actually there is another way to do it. The plus and minus could be the other way around. So okay, we have two possibilities then. We have x squared plus alpha x plus 2 times x squared plus beta x minus 1, or x squared plus alpha x minus 2 times x squared plus beta x plus 1. So the x term will be that times minus 1. So that's alpha x. And then 2 times the beta, minus alpha x plus 2 beta. That should equal 2x, or in other words, minus alpha plus 2 beta should equal 2. Or here, alpha x times 1, that's alpha x, minus 2 beta x, that's equal to, again, 2x. So alpha minus 2 beta equals 2. Now we need to make another equation. I'll do that in red. What'd be the next easy one to get? Maybe the squares. So x squared times minus 1, so that's minus x squared. And then alpha x, so plus alpha beta x squared, and then plus 2x squared. That should equal 5x squared. So let me see. That means alpha beta should equal 5 plus 1 is 6, 6 minus 2, so that's 4. Okay, so I have two equations here now. And then likewise here, the x squared, that would be x squared plus alpha beta x minus 2x squared equals 5x squared. So alpha beta would be 5, 7, 6 then, I think, is it? Now 5 minus 1 is 4, 4 plus 2 is 6. I think that's right. I'll double check it now. X squared times 1, x squared, alpha x times beta x, alpha beta x, and then minus 2 times x squared, minus 2x squared, minus x squared, 6. Yeah, okay. So there are my two equations there that time. All right, let's see. Now, these are going to be integers, so you could probably guess the solution. I can see that if alpha equals beta equals 2, 2 times 2 is 4, and then minus 2 plus 4 is 2. So that's one possibility. Here to get 6, it would have to be a 3 and a 2. Or a 6 and a 1. So if we go with a 3 and a 2 maybe. 3 and 2. 3 minus 4. 3 minus 4, no. 2 minus 6. 2 minus 6, no. Okay, what about 6 and 1? 6 minus 2 is 4, no. And then 1 and 6 then, no. So if I was to solve this, I wouldn't get integer solutions because I've just tried all the solutions. Oh, well, I guess you could have the negatives as well, couldn't you? Like minus 3 plus 4, no. And then minus 2 plus 6, no. Now, I don't think this is going to work. I can't find integer solutions here. So I think alpha and beta are 2. So the factorization would be x squared plus 2x plus 2 times x squared plus 2x minus 1. And then we have to solve it. So I'll just copy that and then solve it on a fresh page. The first one, b squared minus 4ac, and then the second one, b squared minus 4ac. So that's minus 4, and that's 8, it looks like. 4, yeah, okay, so the solutions are going to be x equals minus b plus or minus 2I over 2, or minus b plus or minus 2 root 2 over 2. So that's minus 1 plus or minus I, or minus 1 plus or minus root 2. And I think that's the solution there. That was kind of a tricky one, and I'm sure there was a better way to factorize than what I just did. I'm confident there is, but I got to a solution, albeit in a perhaps ugly way. Okay, I think, let me just have a look here if there was anything else in the question that I might have missed. Find the quadratic factors and hence find the roots. Nope, that was it.